Unexpectedly, this seemingly simple electric kettle contains exquisite physical design. Today we will explore its internal structure and working principle. There are two main parts of the kettle. One is the switch on the top, which is also called the temperature control. The other is the heating component located at the bottom of the kettle, or the steam switch, which is also the core part of the kettle. Resistance coils are usually used to convert electrical energy into heat energy. These resistance coils are usually made of high-temperature materials such as iron or nickel-chromium alloy. In addition, the kettle is also equipped with another key switch called the anti-dry switch. Its principle is similar to the steam switch on the top. Let's first take a look at the steam switch on the top. Its core part is a dish-shaped metal sheet. Here is a key knowledge point. This sheet is actually made of two different metals, usually iron and copper. The thermal expansion rates of these two metals are very different, but they have similar mechanical elasticity, which means that they will stretch and bend to varying degrees during the process of thermal expansion and contraction. When these two metals are laminated together and the temperature reaches a certain level, the metal piece with a high coefficient of thermal expansion will bend more than the one with a low coefficient of thermal expansion, causing the overall bending toward the lower side. With this in mind, let's go back to the kettle switch. When the water in the hot water kettle boils, a large amount of water vapor is generated. It enters the disc-shaped bimetal piece through the small hole at the bottom. The arrival of the steam causes the temperature of the metal piece to rise rapidly. Once it exceeds a certain value, the metal piece will bend and deform. There is a gap above the metal piece. There is another cylinder at the rear wire contact point of the cylinder. When the metal sheet is bent, the front cylinder will rise. Under the action of the lever, the rear cylinder will press down, causing the circuit wire contact point to disconnect, thereby stopping heating. The principle of the bottom anti-dry boil switch is similar to this, but slightly different in structure and triggering temperature. The triggering temperature of the steam switch is usually around 100 degrees Celsius, while the triggering temperature of the anti-dry switch is higher. It is usually triggered when the bottom is overheated. As shown in the picture, there is a piece of metal connected to the metal sheet. Once the cylinder overheats, the metal sheet begins to deform and bend downward, thus pushing down the wire contact piece under the cylinder and disconnecting the circuit. This means that the kettle's protection mechanism is successfully executed. In addition, the bottom of the kettle is also equipped with a small LED indicator light, which is connected to the main circuit connection. When heating, the indicator light lights up. When the circuit is interrupted, it goes out. Finally, let's take a look at the lid of the hot water kettle. The lid will open with just a slight press. This is because there is a special device inside the lid. The front end is stuck in the mouth of the pot. The rear end is connected to a spring. When the lid is buckled, the spring remains released. When the button is pressed, the spring is compressed. The front buckle is released to open the lid. In fact, the structure and working principle of the hot water kettle are not complicated, but it is not easy to design a tool that can benefit millions of families with such a clever combination. Hope you enjoy this video. Like, comment, share, and follow for more 3D animation videos.